Today's lecture is on variation. It's a topic normally used for application. There's some definitions that I want to mention. First definition is, let me fix this. Let k be a constant, non-zero. Then we say y varies directly to x. So you have two variables, you want to show the relation between these two variables. There are two cases. Either y varies directly to x or y varies inversely to x. If y varies directly to x, it means if you increase x, y increases. If you decrease x, y decreases. In the sense that the relation, assuming there is no negative constant, assume the constant k is positive. It could be negative, but at the moment, just to get the idea. We say y equal to kx. That means if you have something like y equal to x, if I increase x and say x from 1 changes to 3, what happens to y? Y from 2, if you replace 1, you get y equals to 2, changes to 6 if you change x to 3. So if you increase x, what happens to y? Y increases as well with a certain ratio. This ratio is that coefficient k is basically tells you the constant variation. K is called the constant variation coefficient. Constant in the variation. Okay, so we say y varies directly to x if y equals kx. There's another way to say it's y is directly proportional to x. By the same meaning that if you increase x or decrease x, y is going to behave exactly the same. How about the inversely relation? Just by the name means if you increase x, the y value will decreases. This is in value. It's not in positive or negative sense. Let's say if x is from 1 turns it to 2, y probably will divide by 2. This is assuming there is a linear relation and stuff. So all the behavior is just that y equal to k over x. If you increase the denominator, which means if you increase x, increase the value of the denominator, what happens is that the fraction gets smaller, so y becomes less. If I decrease the value of the denominator, this fraction becomes larger, y becomes larger. So the behavior between x and y are inversely related. What you need to know is only these two equations. Y relates to x if directly, if y equals to kx, and inversely if y equals to k over x. There are some other methods. Oh, there is something called jointly related. Jointly. This means there are more than one variable. So there's something like x and v. Then y equals k and v. And we say x and v are jointly related directly to y, something like that. And this is multiplication. Okay. Y equals k times x times v. We'll do examples of it, but just in the sense to understand that this definition is basically tells you what is the relation between these variables. Here are a bunch of examples. What do we want? We want to write a model for all these variables. So we have certain variables and we want to find out what is the relation between these variables. Here's the first example. Distance d. So you have a variable d, and this distance is the distance that the spring stretches, varies directly to a force F. This is the other variable. And they want you to write the model for this. So if d is related to F directly, that means d equals k times F. We do not know what that k is. It's just a number. Sometimes they give you extra information and say k is, for example, 2, or give you F and d and tell you figure out what is k. We'll do examples of each. So at the moment, this is what the model looks like. Distance d equals some constant times the force F. So this is the answer to this question. How about another one? A force F, you have a variable F, required to keep a car from skidding on a curved road varies inversely. So here, as the radius r of the curve. So you have two variables, f and r. What is the relation? The relation is that they're related proportionally inversely proportional. So f is some constant divided by r. Again, there is no need to figure out the constant at this moment. You're not given any information about that constant. They just ask you to write the model for it. Next one, a variable a varies, sorry, this a is a variable. Varies directly as b and inversely as the cube root of c. So now you have three variables, a, b, and c. But what is the real relation? A equals, what is the relation between a and b? It is directly, so some constant times b. And what is the relation between a and c? It's not the relation between a and c, it's between the relation between a and cube root of c. So cube root of c is your other variable, cube root of c. Here the variable was b and a. What is the relation between a and cube root of c? It is inversely. So divide by cube root of c. Sorry. Cube root of c. Do I need to write another k? Not really. You just need to have one constant. It's enough to have one constant. Because if you write another k, k times k is k squared is going to give you another constant. It does not mean you have multiple constants. Just one constant is enough to show that there is a number in front. That number could be simply 1. Okay? So find out what the variables are, what is the relation between them. Here's another example. These ones now you're having some extra information. Y varies directly as x. So write the model. What is the model? Y equals k times x. This is a simple model. And now they ask you to figure out what the model is. That means figure out what is that constant k by the given extra information. The information given is x is 8, y is 20. So if x is 8, what would you get is k times 8 equals y is 20. Figure out what is k. Divide both sides by 8. So what you get is k equals 20 divided by 8. You can simplify it. Divide everything by 4, 5/2. So what is the model? The model is y is related to kx, but k is simply 5/2 x. This would be the model for this variation. K and x are really related in this sense. There is no constant k because we figured out what that constant k is. It was 5/2. We went back and replaced it to the original model. Okay, here's another example. M varies directly as x. It's very similar to the last one. M equals k times x. Let's make this maybe it's k times x. We have more examples to go through those as well. So now given information, x is 10, m is 42. X is 10. Actually, I could have said related to x squared, for example, square root of x. Let's change this to x squared so you have the option. K times 10 squared equals 42. And what is so m and x squared are related directly, so m equals k times x squared. M is given 42, x is given 10. Replace those. What you get is 42 equals k times 100 or 100k. So what is k? K equals 42 divided by 100. You can simplify it, divide everything by... You can divide by 6 or something. I'm going to write it in decimal, it's easier, 0.42. So what would be the formula? The model would be m equals, k is already 4.42 and x squared. So in the formula, I replaced k with that. Okay, another one. P is inversely proportional to Q. What does it mean? It means P equals some constant k divided by q. Now, given information q is 18, p is 54, what is k? You can figure out k. If they only ask you for k, you just need to figure out what is k. In the last example here, we figure out what k is. But they ask you for the model. That means in the original model, replace that k value. So here, p is given 54. 54 equals k divided by 18. Q is 18. So what is k? You can multiply both sides by 18. These two can cancel out. This number is kind of larger than what I was hoping for. K equals 18 times 54. 18 times 54. That is 900 plus 4 times 18. What is that? 4 times 18. 2, 4, 72. So 972. Okay, what is the model? T equals 972 divided by Q. Do not replace P and Q with those numbers anymore. These are variable at the moment. So this is your model. But if you want to figure out what K was, you can replace these values into the formula to figure out what that constant K is. And in this case, they only ask you for the model, so this is the answer. Here, one more. Y varies jointly as W and V. As I mentioned earlier, sometimes you have more than one variable. We did an example. Now you have more than 2 variables. Now you have 3. What does it mean? That means Y equals K times W times V. However, W behaves, V behaves. In this case, they both vary jointly, and unless they say inversely, you assume it's directly related. So when W is given 40, V is given 0.2, Y is 40. We want to figure out what is the model. W is given, Y is given 40, K we don't know, W is given 40, and V is given 0.2. What would be K? K equals, if you multiply both sides by 40 times 0.2, what you get is 5. This is a faster way to do it. You can do this calculation, divide everything by 40 times 0.2. 40.2. These two will cancel out. 1 divided by 0.2 is simply 5. So what is the model? The model is 5WV. This is the model for this variation. Here, one more example. This is maybe the most complicated one. I don't think it's really complicated. It's just that they ask you for both variation. The value of y equals 4 when x is 10. Find y when x is 5. Okay, if, let's say this is part A, and this one is part B. Let's assume y is varying directly with x. That means y equals kx. Okay, now given information y equal to 4 and x equal to 10, we should be able to figure out what k is. 4 equals k times 10. Right, we can figure out that k is simply equals to 0.4. 4 divided by 10 is 0.4. So what is the model? The model is y equals 0.4x. This is our model. But what do they want? They want to say, find the y when x is 5. So replace x with 5, figure out what the y is. If they only want the model, this would be your answer. This is the answer if they want the model. But in this case, they want to figure out the specific y value for the given x. 0.4 times x is 5. What is this? 0.4 times 5? 0.4 times 5 is 2. So y equals. There's faster way to do this, but in this case, I recommend to go through this process. The faster way is you say x divided by 2. Since these two variations are directly to each other, then y divides by 2 is 4. Y divides by 2 gives you 4 divided by 2 is simply is 2. Okay. Here, what if the same question, instead of varying directly, what if it was inversely? So the model that you will get is y equals k divided by x. Let me scroll down. Okay, and the given information was, if they give you y equal to 4 and x equal to 10, figure out what k is first. K equals 4 times 10, 40. So the model is y equals 40 divided by x. To all these, there is always shortcut, but I want you to go through the process. After a while, you get used to the method. There is no need for writing every step down. You can skip some steps. Y equals 40 divided by x. Is that the answer? Not really, because we wanted to figure out what is the y value if x is given 5. Divide by 5. What do we get is 8. So now, if you look at this example, what happened? X divided by 10 divided by 5 was 2. That means you divide the values. But since x and y had inverse relation, what happens to the y? Y this time multiplies by 2. From 4, you ended up at 8. Multiply by 2. So the rescaling in this case was linear. But if x and y had if y had the relation with square root of x, then in that case, you should calculate the model based on y equals k square root of x. That's why it's important to not guess, but go through the process. Okay, there isn't much to say about this variation. This is all, maybe this was the most difficult case. I don't think there is any difficulty to it. Do a couple more examples. It's going to be the easiest topic in this chapter. I'm going to stop at this point.